Yep, I'm Andy Gross, ArtV0 on Twitter. I don't suggest that you follow me. Oh, my bad, I'm sorry. Oh, just use this one? Does this one have auto-tune? Yo, hello? Does that work? Alrighty. Sorry about that. All right, so yeah, I'm Andy from Basho. I'm putting a microphone onto my pants. So building cloud services with Riak. A couple buzzwords in there, I'll try to cut through them. This is part instructional on the parts of Riak that are extensible and what you can do and what you can build when you extend them. And part sort of the tale of how we developed our most recent product, the Riak CS, Riak Cloud Storage. So what is a cloud service? Cloud service is something that's web scale. And I know that's a joke now because the 10gen guys went and fucked everything up, but it used to actually mean something. People used to say that without irony. And it tends to mean these things: highly available. And when I say cloud service, think Amazon EC2, S3, stuff like that. But people used to say web scale without any irony. And it just means things that are highly available. Customers have expectations of high availability. That's why they outsource cloud type stuff to other companies. Has a global footprint. The web drives global commerce, so the cloud infrastructure has to be globally distributed too. Should be horizontally scalable for economic reasons. You want to be able to do the standard Akamai, Google, Facebook, whatever model of buying commodity machines and not really caring too much when they die, and writing software for them that can tolerate and even anticipate, or rather be built assuming that that individual servers will fail. And also for economic reasons, you want it to be operationally simple. The cheaper something is to operate, the bigger your margins can get over time. So Riak is web scale. I mean, these are all things that are true of Riak mostly. There's some ways Riak sucks, but mostly I don't think you'd get much of an argument. At least if I told you these are the features on which we sell Riak. Highly available, dynamo architecture, all the cap trade-offs, availability for consistency, globally distributed in our enterprise product at least, horizontally scalable, operationally simple. The last two are really sort of come from our heritage at Akamai and operating big systems there. So take the fact that these are things you want out of cloud services, and these are the things that Riak provides. It seemed fairly natural to use Riak as a foundation for building new products. I mean, we're a company, we're not just going to stop with a NoSQL database. So as you think about the spectrum of things that you can do, and you look at the resources you already have, the code you already have, and you look at some of the problems you face as a business and as a project and as a technology, and this was a sort of natural choice, this model of building cloud services on top of Riak. So when you use Riak by default, or most NoSQL databases, at least those are the scale-out variety, there's all these knobs, all these controls about low-level things like consistency. At least with Riak, you choose between backends. The query model is unfamiliar or more hostile to doing certain things than previous solutions or other solutions may be. Sometimes client libraries are immature. We're working really hard on that at Basho now, but you'll still find libraries that support some features while others don't. And from a business point of view, partially and mostly because of all this, it's very difficult to sell. If you want to scale out a sales force of people, in order to really qualify use cases and talk to customers, you have to know a bit about distributed systems. As a solution, we decided we're going to use Riak as the foundation for simpler use case specific vertical services. The example for this is our cloud storage product. So when you focus on, sort of, I'll call them verticals, in this case, cloud storage, but it could be compute capacity. If you look at Amazon's suite of services, that's what I mean by vertical services, things that solve one problem in a predictable way at scale. Vertical services can provide simpler APIs. In the case of Riak CS, it's the S3 API, which, while not an official standards body standard, is pretty much a standard for cloud storage today. Has way fewer configuration knobs. You don't have to worry about end values and quorums and backends. So it's easier to deploy, easier to operate. And again, in the case of S3, they have existing client libraries sometimes. If you're doing a clone of something that already exists. And because of all this, it's easier to sell. You need a pile of research papers to go sell Riak. You can sell more fine-tuned services like this, vertical services like this, with just a one-page spec sheet mostly. And people in general want to interact with something simple, and that solves their problem. So there's a number of ways that you can do this, and we've actually been talking about this for a while. I mean, at maybe the last 2 Erlang factories and other events, there's been a lot of talks about Riak Core and how you can build applications with that. This is really just another variant on that same pattern. And over the years, I've seen a couple different patterns. I don't usually like to use the word pattern, but I couldn't think of a better one. I've seen a couple different patterns emerge when people want to take Riak and make something else out of it, whether that's strip something away or add something. I've seen a couple different patterns emerge, and I'll just briefly go through those now. So before I really get to the patterns, this is sort of a representation of where Riak allows you to configure it. Riak was meant to be modular. Modularity was always one of our design goals. And we've used that modularity ourselves to build our own products. So in a traditional Riak Core app, Riak Core is an Erlang library. We have rebar plugins that will create the sort of skeletal code you need to create a Riak Core app. Riak Core is the foundation of Riak KV, the foundation of Riak Search. And interestingly lately, there's a company called Tendita, T-E-N-D-I-T-A, that makes a software appliance based on Riak Core with APIs to languages other than Erlang, which was sort of the dream of the Riak Core fans at Basho for a while, but we just really never got around to it. And this is here the structure that these sort of Riak Core apps, these are the types of things you've seen in the past. This is the structure that they tend to take. And it's also, with a lot of things omitted, the basic structure of Riak KV and Riak Search. So starting, making it sort of API-centric, Riak Core is an interesting library in that you kind of write stuff that sits logically above it and logically below it when you write a full application. But your application, your service is going to expose some sort of API. So that's a component. In the case of Riak, that's web machine and protocol buffers. But obviously you need a way for clients to reach this thing. At the very bottom, you have whatever it is your service does. This is specific to storage, so I called it FooDB, but it could be foo anything. This is the actual work that your application, your service does. Coordinating all of that is a an Erlang process that's managed and spawned by Riak Core called a vnode, which is really the interface between all the stuff above Riak Core, the API, and whatever the functionality that your app provides. And the vnode serializes requests. It deals with topology changes, manages handoff when nodes join and leave the cluster, exposes a bunch of stats about how the cluster's behaving, et cetera. And you get most of that for free when you base your application on Riak Core. Usually after, you can call directly from some API module into Riak Core and send commands around, but usually when you're talking about replicated services or complex transactions or whatever, eventually you end up writing some sort of FSM, usually a gen FSM, to sort of manage the communications between your application and all the Riak Core machinery below, namely the vnodes. You typically write an FSM to manage requests to and replies from those vnodes. Using Riak Core gets you a whole lot of stuff for free. In addition to all the functionality, all the intrinsic functionality, you get the whole packaging system, so you can build binary releases with rebar. And part of that is this sort of generic notion of a console module that lets you basically write functions that can be called from an admin script. So if you've used Riak, there's Riak and Riak admin. Those are all shell scripts with pretty easy to understand templates of how to call into the module that, or the application that you've written. And along with anything you add, you get the join, leave, all the core administration stuff that you'd want to do with a distributed application, all the ring management, ring joining, get to monitor progress of data transfer, et cetera. So that's what Riak Core gives you. And that's an example of sort of just custom Riak Core app. There are lots of these out there in various states. There's a lot of them out there in production, actually. I don't know if I'm allowed to talk about where any of them are. But if you search for Riak Core tutorial, one of our employees, Ryan Zazeski, has written some good stuff about this. So you can go to that level. If you're really not writing a database, or you're not writing a storage service, you're writing something that's really custom, there's some complexity here. But this is all very possible and doable. We try to keep the APIs clean and decoupled from any of the stuff that we put on top of it. Oh, and you also get node and ring watchers to respond to changes in cluster membership, et cetera. So as I said, this is the general structure of Riak KV as well, this hypothetical app. When you use just Riak KV, you get some extension points as well. You get pre and post commit hooks. The enterprise replication product that we sell is actually implemented as a series of post-commit hooks. So it's a nice, clean sort of way to integrate other systems. You can imagine if stuff was coming into Riak and you wanted to put it in a message queue and have it go somewhere else, or just in general interface with another system, commit hooks are a logical place to implement that kind of behavior. You can write custom KV backends. The API used to be pretty simple, and it still is, but it's basically get, put, and delete. That's all you really have to implement. You can stub out the other stuff if you don't want to support things like listing keys, or that's not a natural abstraction for your app. But the backend API in Riak KV is also meant to be extensible. And as far as replica placement and replication and request routing goes, Riak Core actually allows you to define a custom hash function for a bucket. So by default, Riak will just concatenate the bucket and key, hash those, and do the consistent hashing, look up, and decide on a set of nodes to handle the request. Things you can do with a custom hash function are stuff like, maybe don't consider the entire key. If you want to enforce locality of certain objects, and those objects have a key structure that gets more specific as you go from left to right, the more you lob off of the right-hand side of that key, the more things in whatever sort of hierarchy you've represented with that structured key will end up living on the same nodes. An example from the cloud storage context is if a file is broken up into many chunks, and the last element of the key is a chunk number, you could use a custom hash function to lob that element off and then get some more locality among files. So these are the basic. There's more, and you can always write Erlang code and get a little farther up in its guts here. But this is basically the set of abstractions that you get, and these are the set. This is more than what we used for the service I'm about to talk about. So again, I mainly just explained all this stuff, but a Riak core application, it's usually a custom vNode implementation and a client API. Usually you end up writing an FSM to just sort of manage communication with the virtual nodes. An example of this that actually I just saw on Twitter yesterday or the day before, something by John Brisbane, which is basically a Riak core app. Doesn't do any storage, but what it does is it dispatches web requests to Masultan, and there were some good-looking graphs. I don't know. It might suck, but it's at least an example of. I don't think it does. He has a reputation for writing good stuff, but it's an example of Riak core, say, as a load balancer. If you wanted to put it in cloud service speak, it would be an ELB clone, if you will. So there's many other examples. And we try to blog about them when we hear of new ones. Here is the approach that we took with our cloud storage product. It's the stateless proxy, and it's implemented, deployed in a separate VM, a stateless client of some Riak cluster. Uses, to the extent possible, just Riak KV for any state that it needs to store. And from that, you get all these great benefits, all these great fault tolerance benefits, because it doesn't matter. The machines aren't really using their local file system for anything other than running the process. Of course, there's various levels. I mean, you can put stuff on there. You just shouldn't necessarily care if it goes away, if the machine dies. In this pattern, the proxies really have no direct knowledge of each other. The Riak is clustered using Riak core, but the proxies aren't, which provides some nice sort of decoupling of the thing that's actually delivering your application and the backend database. And it allows, that property allows it to scale independently from Riak. So you could have, a 5-node Riak cluster and 100 of these proxies if you wanted to. And then just taking it, to its logical conclusion, I guess, is sort of the clustered proxy. As those services get more complicated, it might not be enough to keep all your state in Riak, or there may be other reasons, like just more coupling between proxies for clustering purposes. You might want to use Riak core itself to balance load among some nodes of some proxy app you've written on top of KV. And if these applications have state that they can't really store in Riak for whatever reason, you can use Riak and all its consistent hashing goodness for distribution of proxy state. And I guess you could actually take this a bit further. You could have a type of node that joined a Riak cluster yet didn't participate in the claiming of partitions and was simply basically a listener of events, but one that had knowledge of where the data lived. You can do that, right, Joe? Okay. Yeah. So my point is that there's a number of ways that you can compose these, all with various trade-offs. So as an example, Riak CS. This is our cloud storage product. We announced it Tuesday. You probably saw it on the Twitters. And what it is an S3 compatible cloud storage product backed by Riak. And in terms of the different types of services you can build on top of Riak, this is the stateless proxy. So in other words, this is a horrible image, but these, that's a Riak cluster. This part of it, Riak is obviously all clustered. The Riak cloud storage nodes don't know about each other, don't keep any state. All they really need to know about is a little bit of configuration for what they're going to do and the addresses of the Riak nodes that they're supposed to talk to. So it implements the S3 API via web machine. How many people have heard of web machine? I think people forget about it sometimes. Web Machine's really awesome, and it allowed us to write this API really well and really fast. Well, we didn't write the API, to copy the API. So, I mean, the problem here is that with storing large files in regular Riak is that since we just use Erlang distribution and FSMs, and there's three-way replication going on, and the fact that the object, in transit that's getting requested needs to be fully materialized at many different places in that request path, when you start talking about a service that's actually getting traffic, puts a practical limit on how big of a value you can store in Riak. So what Riak CS basically does is it's another Erlang VM talking to a Riak cluster. Large files, or whatever size files, large is really the interesting case here, come in through the S3 API. And as a result of a file being sent through S3 API, one or more Riak objects get written. The first one is basically what we call a manifest. And really all that is metadata about the content type, very similar to the metadata that Riak supplies. Content type, content length, some internal stuff used by the system, and enough information to locate, obviously, the chunks of that file is comprised of. So as the large file comes in, Riak CS is splitting that into statically sized chunks. The default is a meg, but it's changeable. And when you read the file, you fetch its manifest. The manifest has enough information for you to predict the keys of the file. For example, if you have the content length and the block size in the manifest, you can pre-construct all the keys that you need. And that's really it. These are stored in separate buckets. It's also a multi-tenant API, so there's users and identities, and there's isolation among users. And all that stuff is stored in Riak as well. Things like user authentication data, usage data. It has billing and metering APIs, access control list data. So all of that is implemented in Riak CS, mostly via Web Machine, and all the state is stored in Riak. I didn't do any code line counts, but the number of lines of code in this compared to what's in Riak is minimal. Riak is really doing all the most of the heavy lifting here. So, what worked well? One thing that sort of happened by chance, but was beneficial to this project was that we got involved early with the beta customer and a very minimal prototype, and iterated on that, which we hadn't really had the chance to do at Basha before. And I think that worked really well. And there's plenty of talks and probably a whole track about that kind of stuff, but I'm not really an Agile guy. Riak KV and Riak Core work great. And I think it's a testament to the flexibility of Riak that there were actually no code modifications to Riak required to build Riak CS. Literally, all you have to do is change the back end to level DB in your Riak cluster, and that's it. Yeah, we didn't have to change anything at all. Riak CS talks to Riak through the protocol buffers API, and we didn't have to change a thing. Obviously, as we build more of these, we will run into issues with Riak or things that they can better, and Riak's roadmap rather will be driven more and more by the needs of people, including us, writing applications on top of it, writing services on top of it, as opposed to applications. And because of that, the thing that you write, for the most part, unless you screw it up real bad, inherits all of the great web scale stuff about Riak. Horizontally scalable, fault tolerant, highly available, ease of ops, etc. So our own stuff worked really well. Our tools, obviously, worked great. Erlang, of course. Rebar, who likes Rebar? Yeah, fuck yeah. Quick check is awesome. If you don't test your code with quick check, either shoot yourself or go learn quick check, because it will find stuff that you will never ever find in your code. This weird thing with software is that you write it and you think it's going to do something, and then you run it and there's some observable behavior, and it may happen to satisfy a business requirement, but rarely is it actually doing what you think it's doing. There's a great post by Andrew Thompson when he, another Basho guy also sitting in the back, when he ran quick check against Poolboy, which is our connection pool sort of behavior, not ours, we got it from the community. But basically every part of it was broken in some way, and yet it had passed what was really rigorous testing on Basho's part in terms of how we were using it. So, you know, are those bugs? Yes. Did we see them? No. But those are the types of things, especially, you know, if the fact that we didn't really observe too much of that behavior with the install base that we have is really a testament to the type of stuff that QuickCheck can ferret out. And all the other Basho open source projects that have become sort of part of our tool chains, part of the way that we build apps, things like Logger, Rebar, RelTool. Well, RelTool's an Erlang thing, but you know, Basho projects and the whole sort of Erlang tool chain didn't disappoint. And I said I wasn't going to talk about process. But yeah, iterate quickly with a customer, ship it frequently, small, close team, and the team was grown slowly. I mean, gradually we added more people on. We did things right as far as, you know, most process people would probably tell you. So what sucked? Connection pooling sucks. They say that caching and naming, caching validation, I guess it is technically, and naming are the two hardest things in computer science. You could probably argue that connection pooling is just a special case of cache and validation, and it is hard and it sucks. In a large service, the number of incoming connections, hopefully, if you have customers, is usually going to be greater than the sort of connection capacity of the machines that you're running your database on. So you have, you know, n connections coming in and m fewer m connections going to your database, where m is less than n. So we started with a naive approach: just open a socket. Just open a socket for every single time you need to get something, even if you're doing that 1,000 times per request, and you know, not pay too much attention to overloading Riak. And that worked for testing and getting sort of features going. Once beta customers started pushing on that, that obviously wasn't going to work, and then so we outsourced the job of sort of managing a pool of connections to Riak to some, you know, open source proxy software. That worked for a little bit until it didn't. The details of that are fairly uninteresting. It involves kernel tuning and tuning of crappy open source software. And then we finally wrote a proper connection pool, which I think is working. It is. And we probably should have started and just written a proper connection pool. Next time, if you know you're committing to the project, just write the damn connection pool. Another thing that, this didn't necessarily suck, this is how things just go in an eventually consistent world. You know, a lot of eventually consistent use cases don't need conflict handling code. The stuff that's truly okay with stale data, you don't care. Some of the stuff in the Riak Cloud Storage product, however, is you know, is amenable to eventual consistency. It can be implemented with a Dynamo-style system that allows you to resolve sibling objects. But you really have to cover every case. In this case, it's mostly the stuff around, you know, predictable semantics around multiple writers to the same object in a S3-style bucket inside our cloud storage product. But that was tricky. It didn't necessarily suck. It just takes a long time, and it has to be really thoroughly tested. But again, you don't get out of this necessarily. This is the kind of thing that you have to do. If you could start talking about CAP and then end up here. That, you know, if you're going to lean to the availability side, then somewhere you're going to have to write conflict handling code. In the future, or you know, when libraries are around, or when, you know, we get around to looking at this stuff more, things like CRDTs might help. A bunch of Basho people have taken interest in that, so if you read their blogs, they've probably done more than I have with it. And QuickCheck for all this stuff, obviously, saves the day. Another thing that kind of sucked, we got around it, but lack of strong consistency in Riak. I think by now, every once in a while, someone comes up with a thought experiment that says, no, I really think I know how to do an atomic something or other in Riak. And you cannot do it right now. Am I right about that, Joe?
Cannot do it right
Okay.
now.
And some of the things as per the S3 spec actually require serialization or some degree of atomicity. So we implemented something, it's a stopgap solution. It doesn't have the same availability properties that Riak does. But if I have my way, Riak will have enough of this consistency to get rid of that by the end of the year, maybe. And the thing that sucked probably the worst, is Joe DeVivo here? Is customer environments. You know, you're going along for a couple years making software, writing software, and you're like, yeah, our software's great. We tested the crap out of it. There's no bugs in it. And then companies go and they run it on computers, and those computers are hooked up to networks, and God knows, you know, and those computers have to be acquired and deployed and provisioned, and then those companies have people that go and mess with the computers and break them. Since this is a service and not just a product, you know, one sort of lesson learned is that your product can be great, but if you don't account for the environment that it's running in, it can still look like a piece of crap. So, you know, as far as Riak goes, and Basho open source projects, who knows? I think we'll probably spend more time looking at the whole sort of life cycle of a Riak cluster, from bringing it up to maintaining it, upgrading it, growing it, and then shrinking it when you go switch to Mongo for web scale. Sorry. There's no sales guys in here. All right. What may suck soon? Large Erlang clusters. There's all sorts of folklore on how many nodes Erlang can handle. I've seen various numbers. I've seen some numbers that are lower than what we've seen that work pretty well in Riak deployments, which last I checked was about 150. But I'm not really sure how much further we can take that. So we are of, or at least I am of, two minds about what the solution is. One of them is, since it's a stateless proxy, not bound to any Riak cluster, there's no reason that, you know, stateless proxies like the Riak Cloud Storage service couldn't sort of shard among many Riak clusters. So, you know, make maximum sized Riak clusters, whether that's 150 or 200, however far the native Erlang distribution protocol is going to go, and then shard among them. And that might have some side benefits too, like you can isolate problems to just one group of customers, but it probably has some of the similar problems of sharding at other levels. Or investigate a new distribution protocol. I don't know if there's any official work going on this, and I know that some of the stuff in the runtime really, really wants to have a fully connected network if you want to do things like links and monitors. So I really haven't taken a stab at guessing the complexity of that endeavor, you know, overhauling the actual distribution protocol for you know, 1,000, 10,000 nodes. But I suspect it's not trivial.
Links and monitors across nodes. I mean, that's expensive anyway, right?
Right.
So you could investigate.
Well, yeah, obviously. Yeah, one sort of bullet that I left out of here is relying less on the distribution channel for some of the stuff that we do. Currently, Riak uses the distribution channel for both control messages and data messages. And if, you know, yeah, you're actually, good point, because before we invest too much in this, we'll probably try to use just straight TCP connections more. And what might suck soon? Storage costs. So right now, you know, Riak replicates 3 times within each cluster by default. But when you start talking about many, many data centers, that gets expensive. Erasure coding is a possibility. Everything I read says that, you know, it's more trouble than it's worth. Deduplication, perhaps. All these things add a whole ton of complexity for a payoff, especially when you're talking about a general purpose storage cloud where you don't really have any way to predict how amenable the data being stored is to deduplication or to, you know, whatever solution you want to use to bring storage costs down. it makes it kind of scary to commit to something that complicated when you don't really know what the payoff would be. And then smarter global replication, maybe. You know, you could have objects with the notion of a home cluster, and then they're replicated to a lesser degree elsewhere. So, I'm running over my time almost. Conclusions: Riak makes a great foundation for large-scale internet services. Duh. It's, you know, just, I mean, again, the fact that we didn't have to change a thing in the actual Riak code base to make, you know, a product as significant as Riak CS is really a testament to how flexible it is. Basho will make more of these. People, again, want to interact with simpler things than a NoSQL database. Sometimes a NoSQL database is exactly what you want. A lot of times it's not. A lot of times you wish there was something else providing what you did, implemented on top of a NoSQL database, so you get the benefit, you know, the scalability and fault tolerance benefits without the hassle of the programming model. And again, lots of work to do on these environments, you know, on the customer environments that Riak runs in as we go forward. We've done Riak Control now, which is a web GUI, but we just definitely need to be a lot more top to bottom than just shipping 2 packages of different software. And that's it. I think we have a few minutes for questions. Sure.
How large are the chunks that you divide
The chunks, the question was how large the chunk size is in Riak CS. It's configurable, but the default is 1 meg, which is a perfect size for Riak to just use. And it makes the workload very predictable on Riak as well, since it's all the same size stuff going through. Yeah, we have. I don't have the numbers with me, but we'll probably be publishing them at some point. Yep.
Could your extension points, did you guys consider implementing flow topology on top of Riak? Yeah, I mean, you just need to simplify the caching and all that. It just works.
Yeah. I mean, just hook it up to dev null and ship it.
But bring in some customers as well.
We get enough of their customers already. Cliff?
Well, not that sort of.
Cliff Moon.
Yeah, so how large of a file conceivably is?
In the first version, the limit is 5 gigabytes. I don't think there is a hard and fast reason technically why it was that. I think it might have been the first thing Amazon did, so we did it too. But there's no sort of engineering work, maybe a little, but I mean, there's no like hard cap at that. If you went into the code, you could probably change that. And the current version doesn't support yet the multi-part uploads you've historically needed to, you know, I think they have a per object limit. I think they just raised it to like terabytes, but you do upload many chunks and get chunk identifiers, keep a little state on the client, and then sort of make the file appear once you're done with the upload. But that'll be supported soon too. Mark Phillips. Basho is hiring. An excellent way to talk to some people at Basho, if you're interested in working for us, would be to come to the party that's happening in 30 minutes at Row, which is at Howard and Hawthorne. It's Howard Street between 2nd and 3rd. And there are quorums of Basho people there. Cool. Well, thanks.